Hi everyone, Clint Edmondson from Microsoft. In this screencast, we're going to take a look at how to design a project's physical structure using a component diagram. But real briefly, our business context for this project, our client is Tailspin Toys, a small brick and mortar hobby shop, and they're looking for an online storefront to supplement their in-store sales. Before we start modeling, it's important to take a look at what a component diagram is used for. It's used to visualize the physical structure of a system, with emphasis on the components of the system, their relationships, interfaces, and ports. And it's also important to highlight the service behaviors that they provide and consume through those interfaces. Here are some key design steps to think about when creating component diagrams. First, create your component diagrams to show the major parts of your system. Draw the dependencies between the components or interfaces to show the structure of the system. Use interfaces on the components to show the services that each component provides or requires. And don't forget, in a large design, you can draw separate diagrams to decompose your components into smaller parts. Let's switch over to Visual Studio and design the physical project structure for our application. Here we are in Visual Studio where we left off during the last screencast. I've got our application architecture layer diagram on the screen, and what we're going to do is turn this into a component diagram and flesh out the physical structure of our application. So we will add a new diagram to our design model. We will add a UML component diagram, and since this is an overall application structure diagram, we will call it application component structure. Let's work from top to bottom and start with our website. We'll call this tailspintoys.web.dll. That will represent our web application. We will then add tailspintoys.domain.dll to represent our domain library. Can't forget our infrastructure. Next, we'll add in our SQL data access library. And you know what? We're going to call this tailspintoys.sql repository, using the common domain-driven design notation for a data access layer. We will also have a Tailspin Toys database project. And in our case, this will be literally the database project with all of our scripts to recreate the database. Now we're going to be communicating with a credit card service, so let's do tailspintoys.credit card service agent. But you know what? Our client has not chosen a credit card service provider, so at this time we're going to mock in a simple stub for our credit card service provider. And while we're doing that, make sure we can read it here. Let's zoom out a little bit, move some of this stuff over. And we know we will ultimately have a credit card processor service that this calls to, but let's go ahead and plug that in here and color code it with a color, let's say orange. And put in a note that says our vendor has not yet been selected, so we'll mock this up for the first few iterations. Just to give ourselves a note architecturally to understand why we have a mock implementation in here. There we go. Oh, let's see, one last thing. It's again not part of our solution, but there is an admin interface. We'll go ahead and call it tailspin.admin. Even though at this point it's external, we may get a chance to rewrite this later, but if you remember from our earlier discussions, the admin interface is an existing application that talks to their existing database, and they wanted to deflect some costs and leave that alone. So let's go ahead and change the color on this to red to indicate that it's out of scope of this project. So the blue stuff is in scope, the orange is external to our system, and you know what I'm going to do? I'll leave that blue. I could mark that as a different color to indicate that it's a mock, or we could use the color scheme from our architecture layer diagram if we wanted to get fancy, but let's stick to the basics right now. Alright, so that looks pretty good. Let's start drawing in the dependencies. So starting at our web, obviously has a dependency on the domain. Domain will have a dependency on the SQL repository, which will have a dependency on Tailspin Toys database. Our domain model will have a dependency on the credit card service agent, and they are most likely, all of these have dependencies on the infrastructure library. And I know this ahead of time because our infrastructure library is a library that we've been using on other projects, and it's kind of one of our core strengths of our consulting business, is a set of predefined libraries to help accentuate and accelerate the development of our applications. And we're working our way down. The mock credit card service will ultimately talk to the credit card processor, and our admin application will talk directly to our database. Okay, we're getting close to being done. Let's add in a few more annotations. We know that this credit card service is going to be talking over HTTPS, so let's go ahead and plug that in there, HTTPS, as the protocol that they will communicate over. Our SQL repository will use ADO.NET and T-SQL, and we know that the admin client is already using T-SQL. Now, this is just a nice thing to add to a diagram to help anyone who views it to understand the relationships and the communication protocols between them. Notice the others, we left those alone. That's because in our Visual Studio project, they will physically be referenced together. At this point, I think we have a fairly complete diagram that's understandable by most of our team. If we did want to highlight some of the interfaces exposed by these DLLs, we could annotate that here as well. Let's try that on the data access layer. Let's go down to our database connectivity here, and let's expose these as a set of interfaces. Bring that up around here. We'll call that T-SQL, and we'll have our repository consume that interface. Slide that over here, and we will call that ADO.NET. This is optional, but lets you really highlight some of the interfaces exposed by your components. Might be more useful in a detailed component diagram as opposed to this general overall application structure diagram, but I wanted to throw that in there just to show you how it works. Now at this point I'm fairly happy with the architecture, and I think we've got something to build upon. So I'm going to pause the screencast and build out this structure in our solution. Okay, we're back. As you can see, I've created the project structure based on our component diagram. And just to reiterate the iterative nature of this design process, I made one small tweak as I built out this project structure. I took our Tailspin Toys.database project and renamed it to SQL Database, because in the future we may change database implementations. I wanted to make sure that the repository and database projects aligned closely. So notice I renamed that in the project structure as well as in my component diagram. Let's walk this from the top down again. So Tailspin Toys.web, I created a ASP.NET MVC2 project called Tailspin Toys.web. For the domain model, I created a standard class library called domain. For the infrastructure, I created a standard class library called infrastructure. For the SQL repository, same thing. For the mock credit card service agent, created a class library as well. And now all I need to do is go through and add references between these as I've shown in the diagram. Here are a few tips on building better component diagrams. First, focus on the physical packaging, the executables and libraries. In our case, we also added database because we were going to build a project for database scripts, and that's fine to add as well. Be sure to clearly indicate relationships between components. Most of those relationships in the diagram were simple project references, but where they weren't, I was sure to highlight that in the diagram by labeling the relationships appropriately. You want to be sure and highlight architecturally significant interfaces exposed by those components, and that's what we did between the SQL repository and the SQL database components. Here are some references to help you with your component diagramming. The Unified Modeling Language User Guide 2nd edition, UML Distilled 3rd edition, and the elements of UML 2.0 style. The resources for this screencast, you can download Visual Studio 2010 Ultimate at this link. I've also included the Visual Studio Architecture Team's blog, as well as a link to my blog, where you can download all the materials from this screencast. Thanks for tuning in.